Yes. Right. So if I have a root node, because of only one node is available, this node itself will be selected for child generation. So the node which is selected for child generation, we are calling with the name E node. So now this is my E node, right? So if it is backtracking approach, because of this is the E node, now the child will be generated for this. Okay. So now I have two nodes. One is this number one and this is number two. So next time for the child generation, among these two, which one will be selected? So in backtracking, every time the recently generated node will be selected for child generation. That's why temporarily this E node will be cancelled and number 2 will become the E node now. And that's why next time the child will be generated for number 2, which is number 3, like this. So now I have again 3 nodes. So as per the backtracking approach, the recently generated node should become the E node. That's why temporarily this will be cancelled and this becomes your E node. That's why next time child will be generated for this. So if 4 is the leaf node, means no child should be generated for this. Means it is dead. So because of it is dead, among the remaining 3, which is recently generated, that is 3. That's why next time again the child will be generated for 3 because 4 is dead, right? Suppose the 3 is having another child 5 which is also be dead, means no need of creating the childs. Okay, suppose for node 3 only 2 child should be generated and the 2 are already generated. So if the all the childs are already generated, then also we can call that particular node as a dead node. So now 4, 5, 3, all these 3 nodes becomes dead. So what are the other not dead nodes? 1 and 2. Among these two, which is recently generated? 2. That's why next time your child will be generated for 2, which is node number 6. So like this, it goes on until the complete tree is generated in backtracking. If I use the same thing with branch and bound. So initially I have node number 1. Because of only one node is available, this itself will become the E node. So the child will be generated for this, which is node number 2. Right? Now I have two nodes, 1 and 2. But already one is selected as E node. So in branch and bound, until the selected E node becomes dead, until the selected E node becomes dead, no other node will be selected as E node. So because of the one node number 1 is E node and it is not dead, the next child is also be generated for 1 only. Suppose for this, in this example, at most 2 childs only can be created. So because of the 2 childs are already created, now node number 1 becomes dead. So because of the currently selected E node becomes dead, another node will be selected as E node. So what are the other nodes that are available to me? 2 and 3. So among these 2 and 3, which is first generated? 2. That's why next time node number 2 will be selected for child generation, that is E node. Right? So the first child 4 is generated and next child 5 is generated. Because of 2 childs are already created, now it becomes a dead again. So what are the nodes that are available to me now? 3, 4, 5. Among these 3, which is first generated? 3. That's why next time your node number 3 will become the E node. So that's why node number 6 and node number 7. Like that it goes on until the complete tree is generated. So if I map this concept to graph traversals, every time the recently generated node is considered, as like in backtracking. It is similar to DFS approach in graph traversal. So depth wise, the tree will be generated. If I consider the branch and bound, that is breadth wise, and a level by level. So that's why the branch and bound follows BFS approach. So this is the main difference between backtracking and branch and bound. Okay, so first remember this point before moving on to the topics of this chapter. What is the main difference between backtracking and branch and bound? Okay, right. So totally in this chapter we have three topics. So as like the first one is the general method and two problems. One is traveling salesperson and the other one is 0 by 1 knapsack. Right? So what is the general method? So whatever the things I told until now, that is the same. The state space search methods in which all the children of the E node are generated before another live node can become the E node. All the children of the E node are generated before any other live node can become the E node. So until all the childs are generated, no other node will be selected as E node. Right? So in branch and bound terminology, a BFS like state space tree will be generated. And every time which node we are considering is the node which is generated first. Right? So that's why it is also be called with the name FIFO branch and bound. And in the previous example, whenever the nodes more than one node is available, among those nodes which is first generated. Right? So that's why it is called as FIFO branch and bound. There is another type of branch and bound which is called with the name last in first out branch and bound. Means among the nodes that are available whenever I am selecting, the node which is generated in the last is selected as E node. Means the node which is recently generated. Means as like in backtracking. సో ఇప్పుడు మీకు నేను డిఫరెన్స్ క్లియర్గా చూపించాలి అంటే సపోజ్ నోడ్ నెంబర్ 1 the two childs are generated node number 2 and node number 3. So now node number 1 is dead. So what are the two nodes that are available to me? 2 and 3. So if I consider FIFO branch and bound, next time childs will be generated for node number 2. If I consider LIFO branch and bound, among these two nodes, the last generated node is 3. That's why next time childs will be generated for 3. So clear now? FIFO branch and bound, LIFO branch and bound. Until all the childs are generated, no other node will be selected as E node. That is the common principle of branch and bound. సో ఇప్పుడు నేను 2ని ఈ నోడ్గా సెలెక్ట్ చేసుకున్నాను అంటే దీని చైల్డ్స్ అన్ని జనరేట్ అయ్యే వరకు నేను ఇంకొక నోడ్ని మళ్ళీ సెలెక్ట్ చేసుకోకూడదు. If 2 dead అయితేనే among the other nodes, I need to select another node for child generation. Which node will be selected? Is it based on first come first served or last in first out? If it is first in first out, means the first generated node is the one which is selected. Then it is FIFO branch and bound. If it is last generated node is selected as first E node, then it is LIFO branch and bound. Right? But in both these methods, it takes a long time to generate the answer node. So in state space tree, our aim is generating the answer node from the root node. So if I follow either FIFO branch and bound or LIFO branch and bound, it takes a long time to generate the answer node. That's why both of these methods are not preferable. It takes more time. So because of that time complexity is more, the methods are not preferable. So what I have to do to generate the answer node quickly, still by using branch and bound method, is LC search. So the meaning of LC is here least cost. Means for every node that is generated, we are evaluating a cost function. So suppose for example, the node number 1. So here the node number 1, which is the root node. So I'm selecting this as E node because only one is available. So until all the childs are generated, I will not apply again the selection policy. So node number 2, 10, 17, 23. These will be generated. But what happens in LC search is, along with every node, there is an associated cost that we have to evaluate. And whenever I want to select a node as E node, I will select the node which is having least cost. అంటే నేను FIFO or LIFO ను follow అవ్వను. Selection is based on cost function. Select the node which is having least cost as E node for child generation. Right? So that is the method called with the name LC search, least cost search. That can be called either with cost or rank also. For every node, there is an associated rank or there is an associated cost. So whenever you need to select a node as E node, select the node which is having least rank or least cost. Right? So that is the method called with the name LC search. And this is not required. And this is the main algorithm for LC search. So just look at LC search of a node T. So initially this T may be the root node. So if that T is the answer node, then output that one and return from that. That initially your T is the root node, which is not the answer node. That's why for the first time, this statement will not be true. So that's why I'm assigning that T to E. What is E stands for here is E node. So means whatever the root node I have until now, I'm assigning this to E node to child generation. Right? So initialize the list of live nodes to be empty. So because of this is E node, I don't have any other live nodes now. So that's why initialize the list of live nodes to be empty. Okay. Then for each child X of E, so depending on the problem we are solving, the number of childs will be dependent. So for traveling salesperson, there is some rule to identify the number of childs. For 0 by 1 knapsack problem, there is another rule to identify the number of childs. So how many number of childs depends on what problem we are solving. Okay, so that's why in generally we are writing for each child X of E. Right? For each child we are applying the process. And number of childs, there is no fixed rule. It depends on the problem statement. That's why ikkada for X is equal to 1 to N or 1 to something like that, we cannot write. Because I don't know in generally how many childs are there. The number of childs depends on the problem statement. That's why we are writing a general statement for each child X of E. Right? So for each child, now I am generating the child X. So what I have to check, is this X is answer or not? First I am checking. So if X is an answer node, then output the path from X to T and return from the algorithm. So if this X is the answer node, simply from this answer node to the root node, whatever the path you have, return that path and come out of the algorithm. Because you reach it to the answer node. Right? If X is answer node, if that is the condition, suppose X is not answer node, then what I have to do is I need to add this node to the list of live nodes. Right? So I will maintain a list to maintain the list of live nodes. So I will add this node number 2 to this list. Right? That is add of X. Okay. And because of this is the node which is generated for this E node, we are establishing that child relationship. So that is X of parent is E. So whatever the E node you have, that E will be assigned as parent for X. Because to represent the answer, we need to print the path from the answer node to the root. అంటే ఇక్కడ ఎక్కడో నాకు ఆన్సర్ వచ్చింది అనుకోండి, దీని పేరెంట్ ఏంటి, నెక్స్ట్ దీని పేరెంట్ ఏంటి, దీని పేరెంట్ ఏంటి, అలా రూట్ వరకు ప్రింట్ చేయాలి నేను. సో దట్స్ వై నాకు ఎవ్రీ టైం పేరెంట్ కావాలి. సో దట్స్ వై ఫర్ ద నోడ్ దట్ ఈస్ జనరేటెడ్ వీఆర్ అసైనింగ్ ద పేరెంట్ యాజ్ ఈ. రైట్? సో దిస్ లూప్ విల్ బి రిపీటెడ్ ఫర్ ఎవ్రీ చైల్డ్ ఆఫ్ ఎక్స్. సో ఇప్పుడు ఇక్కడ ఫర్ ఎవ్రీ చైల్డ్ అంటే 4 చైల్డ్స్ అనుకోండి, 3, 4, 5 అండ్ దిస్ 3, 4, 5 విల్ ఆల్సో బి యాడెడ్ టు దిస్ లిస్ట్. Right? If all the childs are over, then this for loop gets terminated. Just a minute. Hello? Hello, madam? Madam, ఎవరికి మా? ఓకే. ఓకే మా. ఓకే మా. ఎస్ మా. ఎస్ మా. ఓకే ఓకే. So, right? So if this loop is over, it means all the childs of E are over. So if all the childs of E are over, then this E becomes dead. So if this E becomes dead, again among the nodes that are available, I need to select another node. Right? So that's why if there are no more live nodes, right, means if this list is empty, it means my tree generation completed without having any answer. That's why if there are no more live nodes, then write no answer node. Right? Ade if this list is not empty, means I have some number of nodes. So among these nodes, now I have to select. So ఇప్పుడు నేను control abstraction for LC search అన్నాను కాబట్టి I need to select the node which is having least cost. So that is the function I called here least. So what is this least function will do is select the node which is having least cost among all the nodes by evaluating the cost for every node. Means this least function first evaluates the cost of 2, cost of 3, cost of 4 and cost of 5. And then it selects the node which is having least cost. And that selected node again becomes E for you. So if that is E, again I have to repeat the child generation. And again ikkadiki vellipovali for each child X of E. Again this should be repeated. That's why all this will be written in repeat until loop. So up to what time this repeat until loop will be repeated? Until any one of the condition which is for return is satisfied. Ante either an answer node is found or my list is empty. Ante no answer. So until either this condition or this condition is satisfied, the repeat until loop will be repeated again and again. Right? So this is LC search control abstraction. If I want to write the same control abstraction for FIFO, then simply you need to write the description for this list in a different manner. Instead of calling list here, you can call as FIFO. So what is the meaning of FIFO? Simply from this list, whatever is the node that is first will be deleted and that is assigned as E. Then the same algorithm will become control abstraction for FIFO branch and bound. Instead of LIFO, if I write here LIFO, then it becomes the control abstraction for LIFO branch and bound. So all the remaining process will be the same. The only difference between FIFO branch and bound, LIFO branch and bound, and the least cost branch and bound depends on among the nodes that are available, which node will be selected as E node. If the first generated one is selected as E node, then it is FIFO. If last generated node is selected as E node, then it is LIFO. If selection is based on cost function, then it is LC branch and bound or LC search. Right? So these are the three different variants in branch and bound. And among these three variants, obviously the time will be minimum for LC branch and bound. That's why